Hello everyone, thank you for watching this video in which I will do some more clarifications about the unit test video. Thank you very much for your questions, really good questions that I've got after this unit test video. And let's see your questions here. Should we test every layer independently? Do you do that in your projects? And then, is TDD a good approach for Spring Web projects? What will be the next lesson? That's the last one is pretty easy to answer you. I will do in the next lesson something about the actuator, and I will plan it very soon. Now, to go back to the first questions, which are the really important ones here. Should we test every layer independently? Do you do that in your projects? This is a really good question. Well, in my case, I'm one of the guys against doing the testing for each layer independently, so I don't do that in my projects. But you will find that this subject is a very debatable one, so I usually avoid the debatable subjects, because you will see that even in different books you find different opinions with different explanations for why and how. And in my case, I prefer, for example, at least in some kind of applications like the usual API applications, where you have just some REST endpoints and that call some functionality in the service and do something, I don't know, work with the database, work with some proxies and so on. Usually for this kind of applications, at least, I only do the integration tests. And the reason for that is that in the end, what is important is the result of the API itself, so the result of calling that endpoint. And I always know, or at least clarify that during my work, what is the expectation of execution of calling of a REST endpoint. So I know which are the cases, I know what should happen. I know when an endpoint should return a 404, I know when an endpoint should return a 401, I know when an endpoint should return a 200 or something else. I know when it should have a body, which is the response body. It is in the end, when you write an endpoint, you know all these things for all the cases, and you know for specific inputs what will be the output. So it's pretty easy to do integration tests, and you don't have to care about the class architecture, and this leaves you a lot of flexibility if you don't need to independently test all the layers. Also, by not testing all the layers, so for example, by only applying the web MVC and the expectations at the endpoint, then you leave your flexibility. If you do unit test, for example, the service, and then you find out that you have to separate some methods, because in the future you will get some functionality to be developed, and then in that functionality you would like to avoid duplicating some code, and you just take out some code and put it in a manager class or something like this, then you might observe that you have to rewrite some unit tests. So unit tests are very good if you really know when you write a method, that method will actually have that responsibility all the time, and the responsibility of the method that you are writing will never change. But when you write APIs, you will see with experience that usually this is not necessarily the case. Of course, if you have an util class, for example, where you have some functionalities that you know they will never change, because, for example, some kind of mathematical operations will always be that, and you will not change that operation itself. It can't change, or it's very unlikely to change, then you will do a unit test, or you will do the proper unit test for that. But when you have business use cases that you are not sure if they will change or not, in my opinion, you should avoid unit testing them if that's not explicitly necessary. So for example, in an just API approach, you test the APIs by using integration tests. They will, being integration tests, they will go up to even in the database if you need, as I have explained in the video. And then if you change the architecture, you can do that without needing to change a suite of tests. and if something is wrong, if you do some mistake and the endpoint is affected, then you have the integration test that will tell you if you have written all the needed scenarios, then one or more of the integration tests will fail, and then you know when you have changed the architecture that you have actually affected the behavior of the endpoint. So this is how I see the things, but again, this is debatable. You will find different answers, and I would really like you to think about it yourself and just take your own path. Is important to have your own feelings, and if you really feel that testing all the layers of an application is the best choice, you should do that. Then it might even be that is different depending on the system that you are writing. I always say that some and most of the things actually are always dependent even on the application itself. It's important even on how you develop the applications, on the teams, how many teams are writing. If there are different modules and they are written by different teams, maybe they have to be independently integration and unit tests and so on. But I think I have at least shortly described my opinion on this first question. And then, is TDD a good choice for Spring Web projects? Test-driven development is a methodology of development in which you are writing first you are writing the test, and then you are writing as short as possible a solution that makes that test workable. This is a really good approach, and usually allows you to develop functionality with the least chances of having mistakes. Also, it allows you from the beginning to make sure that you have tested all the necessary cases. However, even this sounds very, very good. If you are able to apply it, for example, you should do that. But you will also see that in practical situations there is also very unlikely that in all the cases you will be able to do TDD, and the reason is that in general working agile also implies that you don't know from the beginning all the aspects about what you are going to develop. So that means that if you don't know from the beginning what are the expectations, you can't write the tests to make the code working. Of course, you can do that incomplete. You will say, yeah, I know some of them, so I write those, and then I write the code for those, and then you will see that you might need to change tests and so on, and you will find out that maybe this practice will take you more time than needed, depending on how agile are you working. If it's possible, the TDD approach works best from my point of view if you are aware of as much of the functionality from the beginning as possible, and then you know exactly what are the expectations, so you can write the test, and for each test then you will write the needed implementation as short as possible. This is how the methodology works. You write the shortest amount of code in order to make the tests, all the suite of tests run, and then you run again, and then you write another test and then solve that test as well until you finish the entire functionality. As long as you know what you have to develop, and that means that, as I've said, in some agile environments that wouldn't be the case. So it really depends of what and who are you working with and how are you working. But the conclusion would be to make it short and clear. If you can do that, and if you have from the beginning all the needed aspects, TDD is a good and nice approach, and I really like it. I can say I even love it. If you don't have all the needed details for your implementation, you will find it much more difficult to apply, and you will find that it rather takes you more time to get the same quality, rather than if you do the other way around, write the functionality and then cover the main things with unit tests, because you will find the branches in the end after you write the code, being that the requirements will change, will be so likely to change, then even what's important about that functionality will change itself. So in the end you will just be able in the end to find actually the branches that you really need to test, and that you for your functionality represent those things that you want to make sure that if in the future somebody changes something, we'll be aware of the change of functionality on those branches. I hope this answers your question. Please tell me if you have some other things that are not clear, and I will do some other videos to answer them. Thank you really much for the questions, really good questions, and I'm so happy that that you are interested in this subject, because unit and integration tests are a very important part for the maintainability of the code, and every good programmer knows that and applies unit and integration tests in their code, together with working on continuous integration pipeline and even continuous delivery and deployment. Thank you very much, and stay tuned for new videos.